network and application penetration tester at a company called NetSpy out of Minneapolis. And so I've had the opportunity to look at a lot of different apps, big apps, web apps, mobile apps, a ton of networks. And at the end of the day, they always cross over to the database layer at some point. And over the last quite a few years since I've been involved in security, one thing that I've kind of come to the conclusion on is that most development groups don't really understand SQL Server security. They're very good developers, but they're not DBAs. And so that's why I put together this slide deck to basically cover off on 10 practical attacks we use during network and application pen tests that developers are kind of not as exposed to. Although some of them are very exposed to, so it's a little listed. Anyways, on with the show. So I'll be covering off on, I guess I can't walk away from this, but I'll be covering off on why security breaks and where it breaks very quickly. We'll cover some SQL Server security basics so we can kind of have a common language to talk about this. I'll touch on finding SQL servers in your environment, and then also naturally talk about the 10 practical attacks that you guys came here to see. So first of all, security breaks, generally speaking, at the database level for the reasons I just mentioned. Basically, developers, DevOps guys, even IT admins aren't DBAs. DBAs get paid a lot more than I do because they're way smarter than I do because databases can be very, very complicated. So I'm just scratching the surface of some of the things that are probably there. Also, from a development perspective, these are your priorities typically. I mean, I'm not a developer, just as a disclaimer, but this is what I hear from development teams. Hey, first I have functional requirements, then availability, performance, and security is at the very end. Just started in this phase. And then generally that boils down to I don't have enough time. Security is an add-on. As a pen tester, very, very often we come in at the very end of the life cycle, 2 weeks before the application is supposed to go live. And so they just don't have enough time to go back and do everything right. So where security breaks, generally speaking, as far as the SQL Server is concerned, is at points of integration and points of trust. So anytime the application calls into the database, and then you're trying to basically call out to other components that are external to that database, you have to pass credentials, impersonate users, assign excessive privileges, and these are the areas we're going to be talking about today. So those are the things we take advantage of. Those are the areas that break down. First, let's go into the kind of security basics for SQL Server, kind of create a common language to talk about this. I would like to just give a brief overview of what SQL Server is. So at the end of the day, it's just an application that runs like anything else, right? And it runs as a set of Windows services that run in the background. Those Windows services run with the privileges of the service account they're configured with, just like any other Windows service. And so we'll talk about how that can be dangerous a little bit later. But just know it's basically each installation is called an instance. Each of those instances is a collection of separate processes and separate ports. So if you have 2 SQL servers installed on the same box, they're going to be listening at different systems. So I put together a very kind of rudimentary diagram here. So you have the operating system. On the operating system, we have individual Windows services installed. Those are instances. Within each instance, you have individual databases, and then your data is in the tables. So pretty straightforward. So in order to access all of those objects at the different layers, there's something called security principles, and there are different types of accounts that are used to control access to different types of objects. At a very high level, we have Windows server level, so these are Windows accounts and groups, SQL Server logins and server roles, which only exist inside SQL Server, and then the database level. Generally speaking, the Windows Server level and the SQL Server logins are used to sign you into the SQL Server. And then after that, if you want to access data, that login actually has to be mapped to a database user that's created separately within the database level. So I put together a little diagram to illustrate this too. So once again, we have our operating system, we have our SQL Server instance, and then within SQL Server here, we have our SQL Server login that only exists in SQL Server, and then we have our database. There's a database user that's created within the database layer, and these have to be mapped together in order for this user to access this data. And then also, as I said before, you can use Windows Server, operating system accounts as well, so either on the domain or locally. Those are then mapped to a login internally, and then those are mapped to the database, same type of deal. So these are kind of important concepts when you're talking about getting access to the actual data. A couple important roles I did want to touch on. The sysadmin role is basically a DBA. They can do whatever they want within the database server. Pretty straightforward. And then there's this public role, and this means basically everyone. Anyone who can connect to the database has the public, is a member of this public role. I talked about scenarios where that is bad, even though it's considered to be a least privileged role. Next, on the database layer, we have database owners, which are typically the actual login that creates the database. So very often you'll have a sysadmin, right, the DBA, come in, create an application database, so they now officially own that database. And then they might create an application account that can be used to manage everything within the database, and then assign it this DB owner role, so that they're kind of separate, if that makes sense. The one actually owns it, the one's a delegation, essentially. All right. So enough of the basics. Whether you're a white hat, black hat, somewhere in between, if you're going after SQL servers, you want to get an inventory to start with. You can't attack something if you don't know where it is. So the more traditional way to do this is from an unauthenticated perspective, which I've heard from a lot of people, and it's very effective for finding, domains servers, non-domain servers. It can be really slow. You really have to go out and get an inventory of all your subnets to find out where the majority of these things are. Although a lot of organizations will just drop all their database servers on a single or a few subnets. Lots of tools for doing this. Metasploit methods, SQL paying. You can use native stuff that actually comes with SQL Server. The much more effective way to do it, if you're on the kind of the white hat team, is using service principal names. So every time an SQL server is installed on a system that's a part of a Windows domain or Active Directory domain, it registers with Active Directory. So the funny thing about this is that any user in the entire domain can go to Active Directory and say, please give me a list of every single SQL server that's attached to this domain. And that takes about 3.2 seconds in a really large domain. So this is by far the most effective way of getting the majority of your inventory out of the box. There are a few situations where you're not going to get everything if they change the service account later on. So using this along with scanning techniques is probably the best to get a full inventory of your SQL. There are some tools that are native. SetSPM is a native tool that's been out. I think it ships with Windows since like Windows 7. 85 is a third-party tool. It's part of the Joeware toolkit. It's a really big toolkit. Go check that out. And then a script I wrote that's just a PowerShell script for going out and querying Active Directory for different types of service principal names. And here's an example of doing it for SQL Server. I have a very small test lab, obviously you can see here. But in the real world, we dump hundreds and sometimes goes into the thousands of SQL Server instances. So now that we have a list of stuff to go after, let's talk about the 10 issues that we see the most during penetration tests that we take advantage of that allow us to escalate privileges. So the point of these is to show you what happens after, for the most part, show you what happens after I get a set of credentials to get into a database, or what happens after I have SQL injection. We do a lot of interviews of people coming into NetSpy, and we always ask them, what's the impact of SQL injection? What can you do with this? And we hear a lot of, well, we can get data for the database, yes. And they're like, if I'm really mean, I can drop the tables or drop the database because they run XKCD. Which is good, those things are not untrue, but there's way more you can do, and so we'll talk about escalating privileges in a lot of different ways here. So here are the 10. I'm not going to read them off. I'll just kind of get into the details. I should note in the first slide, I showed kind of the SlideShare address. I have already posted these to SlideShare, and I'll leave that up at the very end, so if you guys want to download these, you can. But at a very high level, we're going to talk about login attacks, database user attacks, service account attacks, and some trust relationships that are kind of evil in most environments, cause a lot of problems. These are not prioritized by most likely to be used. They're set up in an order so they can kind of build conceptually on each other. So A builds on B, B builds on C. You'll see what I mean when I get into it. All right. This one's a really basic one. It's a gimme. You guys have probably already seen this 1,000 times. The biggest issue that we see, this is a coincidence, are applications that are configured to connect to SQL Server with the actual SA account or with some other sysadmin. As I just mentioned, sysadmins are DBA. So if I find SQL injection, I'm automatically a DBA. This is a huge problem. It's still 50% of the applications, whether it's a mobile app, thick app, web app, of course, we're always seeing this, on a regular basis. So naturally, we get access to the database that we're in. We often get full access to the entire Windows server through a series of commands that I'll show you in a little bit. And all of this access to data and the underlying operating system is compounded because there's a ton of tools that are free out there. Namely, Metasploit has a couple modules. One's called MSSQL Payload, which basically uses a stored procedure called XP command shell to execute payloads on the operating system. And they have another one to do it via SQL injection. And so the examples I'll show you later I try to focus on the SQL injection because these are the most impactful, especially from an external perspective. All right, so the attack requirements for this are pretty straightforward. If I can get SQL injection or credits from, say, a connection string stored in a web config somewhere that hasn't been encrypted, I'm guaranteed a DBA on the server. The nice thing is it's a very easy fix. Don't use SA, don't use sysadmin privileges for any of your apps, and then do lock them down to only the privileges that are necessary, which in most cases are going to be read access to a few tables or read-write access to like a handful of tables within the database. All right. So next up are logins with the impersonate privilege. So you don't necessarily need to give a login, sysadmin logins are not necessarily the only threat. There are a lot of privileges that can be assigned to logins. It's still allowed to escalate to sysadmin in some way, shape, or form. There is this privilege to allow SQL logins to basically impersonate other users on the fly. And the reason this happens is because developers need to access data or objects that are outside of their database. And so instead of assigning the privileges directly to the user, because we already told them don't make them sysadmins, they're like, well, what if I give them the privileges to impersonate a sysadmin? And so they do that. And then the next round when we tested, this is what we ended up seeing. So it seems like a good idea at first, but what happens, the way this actually works practically, is that this function was intended to decrease privilege, not increase privilege. It was intended so a sysadmin could be creating an application account, and they want to make sure, okay, does this application account have access to everything it needs? So they impersonate the lower privilege. When they're done validating the use case, they then revert back to their previous user context. Anyways, so it's being used to increase, that's bad. And the really bad thing is, whether this is being used in a stored procedure or not, users can actually execute the escalation on demand. And I'll show you the practical example here. Generally speaking, though, the requirements for this are direct connection or SQL injection. Login has been explicitly provided this privilege, so it's not something that happens by accident. And if you want to get sysadmin access, you really have to have the sysadmin or the DBO or whatever, or DBA, allow you to impersonate a sysadmin. However, sometimes you can impersonate, say, a DB owner, and they're not a sysadmin, but there are other steps that can be taken from there, and we'll talk about those steps in a little bit. But for now, let's focus on this. So here's a really simple way to find who you can impersonate. Can you guys read this? Okay, cool. So it's just a basic SQL query. It says, hey, I want to know who I can impersonate personally. My login, anyways. And here we can see SA, my user 2, my user 3. I can impersonate all 3 of those users. And then I can go look up their privileges to see if any of them are sysadmins. So practical attack, if you're doing this via direct database connection, you can start off, say, here and just basically select your current user. So I'm currently running as my user, and I'm checking if I'm a sysadmin, and to return 0, which means I am not a sysadmin. But because I just saw in this slide that I can impersonate SA, I'm going to try that out. And so here I'm actually just running one-liner, so one-liner. Execute as login SA. And now I'm running in the context of that different login. I never had to provide any type of additional authentication token. I didn't have to provide a password or anything. And I'm running in their context. So once again, I run the select system user, which returns my current user, and lo and behold, I'm running as SA. And I double check to make sure that I'm running as a sysadmin, and lo and behold, I am in fact running as a sysadmin. So that was a pretty interesting one that we came across during some pen tests that we fleshed out a bit. Most of these I've written some scripts for to automate, since most people don't remember SQL. I know I don't. So I usually write tools to automate it so I don't have to memorize too much. I wrote this in PowerShell. This is a direct connection. This is a direct connection in Metasploit. And then an SQL injection module in Metasploit. These are already in the Metasploit framework, so if you're familiar with that, just update your framework and get the new set of plugins that's already there. This is out on GitHub, and that location is going to be in the end of the slides. All right, this is just a picture of the PowerShell. Basically, you provide credentials. It's going to connect. It says, hey, you can impersonate 3 users. It will impersonate that user, and then add you to the sysadmin group. That's how all the modules work, regardless of Metasploit, PowerShell, or SQL injection. And here's the SQLi. I think I actually have a video. We'll see if it actually works. All right, cool. All right. So this is the this is the SQL injection module in Metasploit that's out there. And what I was highlighting there is that you have to go out and find the SQL injection first. It's not going to find it for you, but once you know where it is, I should figure out how to pause things. You can provide the actual injection point into the module. It will go out, it will find the initial logins that it can impersonate. It will then determine if any of them are sysadmins for escalation. And then it will actually add your current user to the sysadmins group. So that was via SQL injection. So you're basically just providing the IP, the port, and the injection point, and it does the rest for you. Which is kind of a time saver because, you know, typing all the batch queries can be a little bit of a pain. Anyways, moving on. So the fix for this is just don't use the impersonate privilege. It's not intended to be used as a way to escalate your privileges in a database. You should be focusing on other methods. My favorite method is creating a procedure and then signing it, and then mapping that, basically that certificate to a user that has privileges to whatever you need. I think I laid that out in detail later, so I know that sounds confusing now, but it will make sense in a minute. All right, so as we move on, let's see, this is database users with excessive privileges. So I just talked about impersonating a login that can go to a sysadmin. If you impersonate a login that happens to be a database owner or have the DB owner role, that can also be very useful. So what we actually see a lot of, as I described before, is that you'll have the actual application account that connects to the backend database is going to be the actual owner, either the actual owner or have the DB owner role in that database, which allows them to create stored procedures. And there are other more kind of niche scenarios where users might be assigned the privileges to create arbitrary stored procedures within the database. But usually it's the DB owner role that causes the most risk. And the reason it creates risk is because when you create a stored procedure in a database, you can create it to execute as owner. So it's another way to impersonate users without providing a password or any authentication token. So the reason this is bad is because sysadmins own a ton of databases that we talked about before, so they're the owner. If I create a procedure that executes as the owner, that means I can run arbitrary queries as the sysadmin. So the requirements here are laid out kind of as I just mentioned. You need a database user that can create stored procedures. A sysadmin has to actually own the database, and the database has to be flagged as trustworthy, which I'm not going to get into here, but it's pretty common, more common than you think. So here's an example of our attack script. So I've connected. I realize I am a DB owner within my database. So I'm going to create this cheeky little SP escalating script. It's going to have this clause with execute as owner, which means sysadmin. And then I'm going to go down here and execute add server role member. This is me, my app user. I'm going to add myself to the sysadmin group. This could be any arbitrary query, right? So if you're doing auditing on different groups and stuff, I don't have to add the group, so I can avoid setting off alarms, but for the sake of making this easier, I just left it as my group. All right, so more tools. Once again, we have PowerShell, Metasploit, SQL injection. Just going to skip to the demo. This is a direct connection, so there's slightly different information that needs to be provided to this module. So in this case, we actually need to provide credentials. So this is the actual password, this is the DB owner, user, and you do have the option to provide Windows authentication. So if you're a normal Windows user and you want to see, do I have a DB owner somewhere, you can do that. But it will run, it will check to see if there's any trusted databases that are actually owned by sysadmins. So once again, you guys don't have to worry about the queries. And then after that, it'll go ahead and add you to the sysadmins group, just like the other one. So it all takes about a half a second to run, as you guys can see. All right. So The idea here is when you have a stored procedure that's going to execute as the owner, regardless of whether it's a sysadmin or not, you're probably giving that stored procedure too much privilege, right? You're not practicing use privilege. So generally speaking, go with the cert signing again. Don't allow sysadmins to own databases. That's going to reduce some of the risk of these. What else do I have here? Don't flag databases as trustworthy. This is kind of a big deal. There's lots of attacks that have much bigger impacts if the database is set to trustworthy, which means your current database is trusted by the whole server to reach into any other database and interact with the operating system, things like that. All right, everybody's heard of SQL injection. I know this wanders off the configuration a little bit, but we're going to talk more about impersonation, stored procedures. It's something we see fairly regularly during app pen tests, so that's why I'm bringing it up. This is stored. The difference here is it's just at a stored procedure level. We're not talking about the application. We're talking about a dev guy who basically goes into SQL Server, creates a custom stored procedure, and then once again wants to have it run with more privileges than the app user actually has been assigned. So the reason this is an issue, I think if you're here, who hasn't heard of SQL injection? Okay, kind of figured. I'm just going to burn through this then. Basically, dynamic SQL is being used insecurely. No one's using parameterized queries. If you want to get sysadmin, basically, they have excessive privileges assigned to at some layer. This is a problem because you can execute arbitrary queries kind of across the board. And one of the big requirements, aside from the connection in dynamic SQL, is concatenated strings. So we've probably seen this 1,000 times in training, practical attacks, etc. There are two situations that I found that can be leveraged to escalate privileges in SQL Server. The first is with execute owner. So we saw that before we were making it. This time somebody else made it. We're taking advantage of it through SQL injection. You can also have a stored procedure run with elevated privilege if it's signed with a certificate login. The first one requires the database to be trusted. The second one does not. So this is overall a better solution for escalating privileges securely. But it does have the downside of being pretty impactful, even if the database, I'm sorry, being pretty impactful even if the database isn't trustworthy. So here's a quick example of the dynamic SQL. In this example, I'm actually searching for stored procedures that have been created to run with an elevated privilege using cert signing. So all this code is actually out on a blog I put out a couple of weeks ago, so if you guys are interested, you can check out the next slide blog there, or the slide deck later. Anyways, it's pretty easy to find as a sysadmin. As an actual attacker, it's a little bit harder. A lot of the SQL injection you do in stored procedures is going to be blind if you don't have the privilege to view the source code of stored procedures. And that's about a 50-50. 50% of environments I can see it, 50%. Anyways, here's string concatenation. Here's SQL injection. Here's what it looks like when the code's completed with the injection. And here's what happens when we actually do it within Management Studio. Basically, it just returns the mask, our query was to return basically a list of databases on the server, including master and then whatever we're querying for. And it returns that, but then it also executes an operating system command here, checking to see what account's running the service for SQL Server. Anyway, so that's bad. Don't do that. I didn't go too crazy with this one. I just wrote basically an exporter for stored procedures. We'll go through, look at all the databases that are accessible, try to determine if it can read any of the source code, pull out the source code. And it does have, I did add some switches that I don't show here that will look for common SQL injection strings. So it's basically prepping, through all the TSQL source code for you. So this is way more effective if you run it as a sysadmin. If you're an attacker, you run it with less privilege, you're going to get less data out of it, obviously. And then it puts it in a CSV and such. So anyways, use parameterized queries. Don't concatenate. Don't use execute as owner. And don't flag databases as trustworthy. This is the solution I was talking about before. So if you do want or do have a need or requirement to run some of your queries or stored procedures with elevated privileges, you don't want to give that privilege to your database user or login, you can do this. You basically create the procedure first, You then create a cert, you create a login that you map to the cert or is generated from the certificate. You only assign the privileges you need to the cert login, and then you sign the procedure with the cert. So then when it runs with the login that was generated that you assigned privileges to. So it's a really good way to create granular access to kind of privileged objects. And that's the preferred best practice for Microsoft too. It's a little complicated and convoluted, especially when you're working between databases, but it's a good route. Okay, so the fixed code would look like this, right? We're not executing its owner because it's signed. We're not concatenating strings. We're just passing. All right. This is a fun one. So a lot of people will follow hardening guides and will say, I didn't assign any excessive privilege to anything. It's clean out of the box. It's SQL Server 2014, 2012, whatever. So it's got no bugs. There's nothing you can do with it if you get SQL injection. And so these are the attacks that you can do as public that are getting us into boxes, which are kind of interesting. So dangerous procedures and functions are everywhere. They're available to the public world by default, which once again is everyone or all logins. The impact varies a little bit depending on procedures, and there's a whole lot of procedures that are accessible. I'm going to highlight 4 of them. Registry being the first one. So this is a extended store procedure that interacts with the registry. It's intended to let you read different values from the registry, and anyone can run it. And what we found is that in most environments, the service account, the Windows service account, is running either as a local system or an administrator. And when you execute this stored procedure, it runs with the service account's privileges. So if you're running your service account as a local system, a public user can now read everything in your registry. Everything. The only thing I haven't been able to pull out successfully are some really large like certs, because it gets truncated and gets screwed up. Everything else you can pull from registry. I'll let your imaginations go wild with that one. The next one is XP Directory, and this is intended to provide recursive directory listing on your current server, but it also supports UNC paths, which means I can try to list directories on remote servers, including my evil one, where I ask it to authenticate to me and I capture its password hash, and then I can crack that offline and then get access to the server. And I'll show that scenario a little later too. But Carl here has actually done a lot of research in the cracking area, and we can now crack 35 billion password hashes a second, which usually means once we get your service account password hash as public, it's under a minute, on average, under 30 seconds or something like that, that will have the password and be able to use it to get data and system access. A little less impactful, but still really interesting, are these 2 functions. They allow you to enumerate all of the SQL Server logins and all of the domain users on your network as public. And so by default, you shouldn't have the rights to basically view a list of other SQL logins that are on the server. Sure as heck aren't you supposed to be able to view other domain users. The attack requirements for this are pretty straightforward: SQL injection, direct connection. And I thought for this one I would go through the domain users because it is very handy during external penetration tests at the network layer. And I'll kind of show you why in a sec. So when you install your SQL Server on the domain and say you're an attacker coming at this, this is easier to see in Management Studio as opposed to doing SQL injection, so I'm just keeping it simple. But the first thing we need to do is get the domain of the actual SQL server that it's installed on and attached to. And so there's a nice native function that will return the demo domain. So this is the domain that I set up in the lab. Once we have the demo domain, we can then put together basically a known group. We know domain admins is a group that exists in every Active Directory ever since the beginning of time, basically, right? So we can then use that knowledge in this function called XUser_SID to return the actual SID, or the RID, the full RID of the domain admin group. So every domain has a unique GUID looking thing, and every user has a number that's basically just glued on or concatenated to the end of that. And that's what we get right out. We get that right out of the gate. So this is the long RID that we get, and in order to basically get information about other domain users that we don't know about blindly, we're going to start by getting the SID of the domain, and that's just the first 48 bytes of the RID. So we're here in the red, that's the domain admin's RID number. This is the unique value for the domain. We cut that off the end. And then we just start fuzzing the last number, but we had to put it through a few calculations first. It's not really a big deal. Say we start with 500, which I happen to know is a domain admin or default administrator by default. We convert that to hex. We then pad that out to 8 bytes, and then we just glue it on the end, just like we just saw returned by the other function. And then we can pass that into a different function called suser, sname, and it actually returns the demo administrator account for us. So we've now enumerated a domain account, possibly via SQL injection, without any knowledge of the account. We basically started from scratch, which is cool. So what we do is we increment that number, and then we repeat it like 10,000 or more times. We get every, not just account, we get every domain account, every group, and every computer on the network. So now we're outside the network via SQL injection. We don't have any other avenues of attack. But now we have a full computer list of everybody on the domain. We have all the users, we have groups, and from a pen test, that's a guaranteed in. Because what we'll do is we perform dictionary attacks kind of horizontally across those user accounts, right? We have 10,000 valid accounts, and we're just going to try, I don't know, winter 14. Anybody ever use the season year combination? You don't have to raise your hand. So we'll use that across the environment. We only have to use a couple, and we're pretty much guaranteed in. We come in through, say, single-factor VPN, RDP exposed to the internet, Citrix, any app that supports NTLM authentication back to your AD. So there's lots of public web access, I think, is another really common one, to do the dictionary attack externally. And then we can actually jump into the environment. And for those of you who are not as familiar with network penetration testing, it's very proceduralized, very streamlined, and at this point it's 2 to 5 steps to become domain admin, and now I can get access to every other database in the environment at that point. So it doesn't seem bad at first, but it leads to bad things, and that's kind of the point I wanted to make with some of these. More tools. I wrote a couple tools for doing the SQL login enumeration, which you can then use for dictionary attack on the SQL server layer, and then stuff at the actual database layer. I think I have an actual demo of this. So once again, here, we're going to specify our SQL injection point. And I should comment, this is, I actually bumped this down a little bit from the default, because I have a small environment in my lab. But, what was I going to say? I don't know. Anyways, I'll get back on point. All right, so here's the URL. You provided the SQL injection point. The fuzzy person will go enumerate the server name, the domain name, get the SID of the domain, and then it's going to start fuzzing using the method I just described and demonstrated. So here we can see we got administrator, so it's finding domain users. Boom, we got the enterprise admins group, it's finding groups, and it's also finding computers. So anytime you see an account with a $sign at the end, that's a computer name. Drop the $sign and you're good, basically. So I'll go through, it's a very small environment once again, but this is all done blindly through SQL injection. That brings me to my point I was going to make, which is something. Yeah, definitely. Now I forgot it again. Oh, the SQL injection. So all these SQL injection modules are error-based SQL injection. So you need to be able to generate SQL injection that actually shows an error on the page. Some of the other things we've done in the past do blind and we have union-based, select-based type of stuff. But this is just simple for POC sake. So I'm sorry to disappoint if you guys are looking for blind out of the gate. Anyways, all right, so generally speaking, this is a pretty easy fix. You just have to go a little bit above and beyond your standard configuration. You need to deny execute on those dangerous store procedures and functions to the public role. And there's tons of hardening guides out there, including Microsoft, who has quite a few that are worthwhile to take a look at. All right, so now let's dive into the SQL server accounts, our service accounts a little bit. These also very often have excessive privileges. I touched on a moment ago, like you'll see many of them with local or domain users that have local administrative rights. We also still see about 2 in 10. The service account has domain admin privileges, and that's the 2-step escalation process I was talking about. If someone comes in and does SQL injection and the SQL login used by the application to connect to the backend database is a sysadmin, they're guaranteed DBA. And that means they can execute on the operating system under the context of the service account that's running on the operating system. And if that is domain admin, you're basically done in one injection. So they can do anything they want with your environment at that point. So that's really, really dangerous. We don't see it as much. It used to be about half the environments, but about 5 years ago, people started making changes thanks to PCI, I think. Those auditors get you. The other bad thing we see a lot of is shared accounts between unrelated applications. So people will create domain accounts that are used to run the services on SQL Server, and then they'll use that across every app. So they're not just using it for the bank app, they're using it for the blog app, right? These should have no inherent trust relationships, but they do. And so this is bad because the service account inherently has sysadmin privileges. So I find an SQL injection, I take over the blog site, and now I'm running in the context of the SQL Server service account through different methods. So with my sysadmin privileges, right? So I can go through XP command shell. This is the classic one everybody talks about. There's also the SQL Server agent that runs different jobs in the background. This is actually used a lot more than I thought. And it has a ton of ways to execute operating system commands. And then you can always just create your own. So you can actually put your own DLL to do whatever you want out on a UNC path somewhere, and then once you're sysadmin, you can just like load it in and you're good to go. So that's pretty neat. Lots of options is the point. Oh, and like I mentioned before, don't forget, public logins can steal your service account passwords through XP directory and those other file exists and some other functions. At some point, I'm going to release like a laundry list of things you can use for UNC path injections. But just know that they steal that service account and it's a game over. And we do that on half the pen test, half the network pen test, and almost anywhere SQL injection is, we pretty much exercise that attack, which is really interesting. All right, so the attack requirements here are, right, I need some access to the database. Service account has to be configured with local or domain admin privileges. And then you need some access to XP command shell. This is your sysadmin scenario, or XP directory or file exists, something that I can throw a UNC path into to basically send me a request for authentication so I can steal the service account's password hash. So as a sysadmin, here's a really basic example, super, super basic. You can use XP command shell, who am I, see what I have. Oh, my service account's running as an administrator. That's really bad. Microsoft has gone through a ton of revisions on their hardening guides that go into very specific detail on what registry keys you need access to, how much file system access you need, all this stuff. So you should never have to run your service account as a local admin. A local system. Please don't do local system. So here's a basic scenario. This is from a presentation we did a long time ago. But internet, basically there's a hole in your firewall that allows users to hit your web server. There's a DNZ firewall with a hole, so the web app can talk to the database server. And here I'm a sysadmin. I can run XP command shell, and now I can run OS. The first example we had was OSSQL, or OSQL-E. So this is a command line utility or client for SQL Server that is shipped by default with every version of SQL Server. I think SQL CMD is replacing it in 2014. But they both support this nice little -E switch, which means use integrated authentication, which means I don't have to provide a password to query this server from this server. So once I'm running as a service account, I can actually attack other databases without ever providing creds, dumping hashes, anything. So it's pretty nice for traversing the network undetected. And there's very few anomaly-based detection that catches this type of activity. I don't think we've ever been caught on the database level traversing the environment. The other scenario that I wanted to just touch on briefly was I don't necessarily have to capture a crack. Not everybody has a giant cracking rig at home, right? So as an alternative to this, we can use something called SMB relay, which is basically where we're going to be getting the server, right? We're going to connect to the server and say, hey server, can you please authenticate to me via, that XP directory, right? Forces authentication. I now have the authentication. I'm going to forward it on to another server that trusts the service account. And once he verifies that my authentication is good, I can then push whatever commands I want to this server. So once again, I never have to know the password of the service account to use it to access resources on other boxes. So that's just another way to do that. I do have a very quick demo of that. So this is a little confusing, but this is my low-value application database here. It's running as a DB service account, which is configured as a local admin, which is what we're duplicating. This is the front-end application that's associated with that back-end database server. As an attacker, I come in, SQL injection, that's bad. So now this is a separate database server. This is DB1, which runs a completely unrelated application database, but it's still running with the same service account because it's easier to manage. That's why people do this. So what I can do as an attacker is I can start my SMB relay module in Metasploit. And then a while ago we wrote this module, NTL. It's basically going to execute that UNC path stuff that I showed you earlier. It can be done via SQL injection. So once again, we have to know the SQL injection ahead of time. We're going to put a little tag in there to indicate where it should be doing the injection. Set a remote host, which is going to be the place we're forwarding our authentication to, or the system that we want to take over. I'm a slow typer. Okay. Here we go. I'm just reiterating that. And then here as an attacker, this is emulating internal network, but I'm checking my IP. So I'm going to set my IP as the SMB proxy IP. So I'm basically going to tell the server, hey, authenticate to me. It's going to hit me on the SMB proxy, and then I'm going to forward it off to DB1. So here we go. We're going to run it. It runs. This is the injector, UNC path, does all the authentication for me. I've already obtained a shell on the box. I mean, it runs pretty fast. And then here we can see, well, a couple sessions. And then with Metasploit, you can just drop in, and you basically have an interactive console on DB1. So that's all done through SQL injection. So I was actually, the funniest thing is I'm attacking LVA, or I'm sorry, the first database server, but I actually got access to the second database server. And now that I have that access, I can go back into the first database, and that's my real target. So lots of fun. Anyways, lessons here. First of all, for the SMB relay stuff, if you add signing as a group policy, it should prevent that. It'll do the validation of all those packets, but it generates a lot of extra traffic on your network. So just be aware of that. That's going to be a problem for you. On non-clustered servers, don't run anything as a local system. Don't run it as a local admin. Definitely don't run it as the main admin. And if you can, run it as these new virtual service accounts. These are a really cool thing that Microsoft has done. So in the past, you might have tried to use a network service account, which has very little privilege on the local box and very little privilege on the network. But the downside of this is that there might be other Windows services that also run with this generic network service account. So say I'm in my SQL server, and then there's the hard drive encryption software also running as network service. Just a bad example. I should now be able to manipulate all the files in that directory, which shouldn't happen. So Microsoft's solution to that is these virtual service accounts, which is basically a sandbox version of network service. So it still has limited privileges, but they give it its own unique identifier and can apply access controls within its sandbox, which is nice. Now, clustered servers, an SQL server are a little bit more complicated. They require a domain account to run because they have to have trust relationships with failover and all kinds of stuff. You can still use shared service accounts because it's a requirement. Just make sure that you're not using that same service account across different applications. So just keep it to the cluster, and every app cluster should get its own service account so that those are isolated a little bit. All right. So here's another interesting one that we've talked about a little bit in the past. It's domain users assigned with excessive privileges. And the issue is that, well, there's two issues really. The first one is that SQL Server Express by default includes built-in users. They provide built-in users with the ability to log in, and some database admins also provide that access when they shouldn't. As a result, this is kind of like a privilege inheritance illustration I'm not going to get into because I think I'm down to 5 minutes or 4 minutes now because I started a bit late. But anyways, just know that if you install SQL Server Express on a domain system, any domain user in that network can log into your SQL server. So that's really bad in development environments where they're still using shared accounts across all these different boxes, but now, since they're running Express, everybody in the environment can log in. And we find this in literally every environment we do a pen testing. Please.
Why can't you just after the fact just manually log it in?
That's what people should do. Yep. I mean, to your exact point, if I, whoops. Let's see. It's going to do a bunch of stuff. yeah, don't add the entire domain users group. You should just never do that. I know people do it because they're strapped for time and they don't understand what privileges need to be provided. But from the Express perspective, just remove this group. We talked to the guys at Microsoft and they were like, yeah, we'll try to do better documentation, but we're going to leave it in for Express. It's like, okay, whatever works. All right, I think I'm down to like 2 minutes. Database link chain is also super, super bad and completely awesome to exploit. Basically, it's a database. Everybody know what an ODBC connection is? Right, it's like that between databases, right? So it's a pre-configured set of credentials that allow database A to talk to database B. And what we figured out is that you can chain these like this. So I can come in as an attacker, SQL injection to server 1, I have no access, but there's one database link on the server, it's least privilege. Good for the person who configured it. I can use that using open query, which is a function that's native and accessible to every public user. Get on server 2. Oh, there's a link on server 2, it goes to server 3, great, still least privilege. I have data access on both these servers, but I'm not a sysadmin, so I can't escalate fully in the environment. Sometimes. And now I'm here, I say, oh, there's another link. Oh wait, this link from 3 to 1 is configured as a sysadmin. So now I have sysadmin privileges on this box. Very often I'm traversing different network zones, so I'm in a user zone and I end up in a PCI zone, for example, or somewhere where there's regulated data. And then using XP command shell or any of those other methods I talked about, we push PowerShell injection, PowerShell payloads. It basically executes the shell in memory, nothing ever touches the disk, and now we have a shell on the bottom. So this gets really crazy. We see this in about 50% of the environments where we see SQL injection. Max number we've seen is 12 hops. That means we literally hopped through 12 servers to get where we needed to go or to get the access we needed, and then took it over. So we automated it naturally because the queries just get ridiculous. And the max we've crawled, unique ones, is like 226. About half of those are sysadmin access, which was pretty awesome. Sorry, pretty horrible. So those are things to be aware of. You can also dump the cached passwords as a sysadmin on the box through a bunch of methods. Auntie just posted a blog on this like yesterday or a couple days ago, so go check that out. That's on that side. We already have tools, one for direct connections, one for SQL injection. They're really cool. I share the video, but I don't have enough time. I do have it on my SlideShare deck. All the videos are baked into SlideShare, so you can check out those later on if you want.
Where?
I will. I'm sorry.
Yeah, where do we check them out?
I will put that will be my last slide. I'll hold it up for you guys so you guys can write down the location and hold it offline. All right, so we can default passwords. Bad. Still really common. Test, vendor passwords. Change them. Nobody does. Super boring stuff. Apply strong password policies to the server. They can be inherited from the domain. If you're lazy, it works really well. Other funny anecdotal stuff that I'm not going to talk about. No transport encryption. So by default, SQL Server communicates completely in clear. So if I get a man-in-the-middle position, that means I get your data. And oh, by the way, you can do an SQL injection on unencrypted database connections. So I can do that SQL injection like without an app, which is kind of neat during pen tests. There's a couple ways to do this. If you're on one of the compromised systems in an environment that's talking to the backend database, you can use Echo Mirage, maybe. Inline, you can use EtherCAT and filters. And I just saw this looking at the lineup. Sorry, please.
See 2014 out of the box is encrypted now?
Good question. I didn't test this on 2014. So I don't know. 2012, yes, it is unencrypted. 2014, I don't know. So there is a talk tomorrow and a day on this SQL Viking, and this is a toolkit specifically geared towards pillaging data and injecting into live streams. I don't know these guys, and I haven't actually played with the product, but I looked at their GitHub before I came in, and it looked really neat, so I just wanted to plug them because it's a cool looking project. Yeah, requirements for this are access to the server or a man-in-the-middle position, enable SSL encryption if you don't have it encrypted. I would mention maybe even for the 2014 stuff, some people have trouble, and we've had a lot of clients who struggle with figuring out how to manage their SSL certs and their trust chains, all that stuff. So sometimes that gets in the way, even with newer implementations. Anyways, what can be done yet? Prevent unauthorized access by enforcing least privilege in all the places I talked about. Use secure impersonation methods, namely the cert signing that I talked about. Use parameterized queries across the board. And then there's all kinds of ways to detect attacks. You know, it's nice to be able to prevent it. You should still do all these things, but at least know you're being attacked, because someone who has a foothold in your environment can spend months, days, weeks, years, whatever, grinding. And if you have just a couple simple flags, you're going to at least get tipped off and be able to do something about it. All right. So here's the information I was talking about. I'll tweet out the link in a sec. It's _no bind. Sorry about the Twitter handle. It's weird. I did it before. I was thinking better. And then SlideShare here, slideshare.net/no bind. And then the NetSide blog has a lot of info too. But this specific deck will be the first slide deck on this. So I apologize for rushing through so much of the content and not staying on the timeline. But are there any questions with the few moments we have left?
Well, question about default vendor SA passwords. Like,
Sure.
What's the best thing to do when the vendor has to have an SA password? Like, you changed it, but it's either baked into something or baked into like their upgrade. So if you change or do anything else, it messes up a whole bunch of stuff. Because I've done that a couple of times where I change the SA password and all of a sudden, everything breaks. The actual utility doesn't work and there's no way to go and change it.
Because they hard coded it.
Yeah, absolutely.
Thanks, guys.
Right.
So if it's .NET, decompile it and change the password, decompile it, or modify the bytecode, which is probably going to void your service agreement. But aside from that, our clients have really had, the question was, if a vendor has created an application that basically has SQL Server connection strings baked in or compiled in, what do I do about it? Because I want to be more secure, right? But they're kind of tying their hands a little bit. Usually we have to push back on them quite a bit, and the clients that we have had have basically come up with contracts that have language in it that say you have to have secure software that allows us to enforce strong access control, et cetera, and meet our security policies. So that's the best we've been able to do, short of hacking our own software, right? So, good question.
In addition to your pen test, you guys also perform database scanning. And do you know if some of the database scanning utilities like DB Protect and stuff like that catch any of these vulnerabilities? I saw a lot of them, that it would hit, but some of the new ones like the traversal one, the OpenSet.
It will cover some of that. I haven't used DB Protect in particular. I've used a few other database scanning tools. They will say, hey, public has too much access to these things. Or they'll say, hey, you have links. You should probably go look at that. We don't know context, right? But it's usually within the context of a single server, and it doesn't show the whole ecosystem.
Yeah, it's not like that one graph you showed where you were linking like 4 together, using the traversal.
Yeah, the database links are really crazy.
I figured that scanner would be hard to find that, right?
Yeah, that one I have not seen a scanner that has found it. Once again, because everything's in a silo. They're like, okay, this is going from server 1 to server 2, but it's least privilege, so we're good, right? And they move on, not thinking about the trust relationships down the line. Whatever. But yeah, that's a good one. I should probably contact
Is your code for that one on your site?
Yeah, so I have a GitHub too. It's nobind, whatever, github.com.
I was wondering for that particular exploit scenario.
Yep, one of them's in Metasploit already. The direct connect is. The SQL injections in my cache of random Metasploit plugins. I had to clean it up because there's lines that are more than 100 characters and I don't think so. And there's other reasons too. I'm not really good at Ruby and they are, so they're giving me good advice to fix it.
Cool.
But, let me see. Might be able to bring it up. So there's the GitHub. That's it. It's all out there. So. Well, thanks guys for coming. Anybody else have questions? Okay. Yeah, I should tweet that up. That was